Good afternoon, everyone. I'm Prashanth from Cisco, and I work on the Cisco Umbrella or OpenDNS resolver team. My colleague Brian Sommers, that's listed here as a co-author, is unable to make it in person. Before I start, I want to say thank you to ICANN, VNNIC, and OARC for running this wonderful event, allowing me to be a part of it. I've thoroughly enjoyed the conversations I've had with each one of you. So thank you. So the agenda for my talk today is going to be to give you an overview of the OpenDNS resolver service. I'll also talk about a little bit about Fedramp and FIPS and OpenSSL and FIPS as well, and all the options and nuances that come along with OpenSSL 3 that we've been using. I will go into what does FIPS compliance mean for DNSSEC, DO and DOT, and DNSCrypt as well. Pretty much our take on it, and some other considerations too, if I have time. Right. So OpenDNS is a company that provides public DNS resolver service. It was founded in 2005, and then in 2015. It was acquired by Cisco and has now been rebranded as Cisco Umbrella Resolver Service. So if you hear the term OpenDNS or you hear the term Cisco Umbrella Resolvers, it essentially means the same service. So it is confusing, but it means the same service. Just to talk about our scale, we get anywhere between 600 to 700 billion DNS requests a day. Sometimes it goes into trillions. And we have a global presence. We are in 40 plus data centers across the world. Why Fedramp? Before answering this question, I do understand that many of you may not be familiar with what Fedramp is, so I'll take a moment to talk about it. Fedramp stands for Federal Risk and Authorization Management Program, and it's a United States federal government-wide compliance program that provides a standardized approach to security assessment, authorization, and continuous monitoring for cloud services that deal with the government. There is another acronym which I will repeatedly reference, and that is FIPS. For those of you who don't know, FIPS stands for Federal Information Processing Standards. These are a set of publicly announced standards that NIST has developed for use in computer systems. FIPS standards establish requirements for ensuring computer security and interoperability, and FIPS is almost an integral part of one of the Fedramp requirements too. So why Fedramp? Pretty much it's all business in order to explore opportunities within the US government and possibly other entities that supply services to US government. We were asked to build a new Fedramp infrastructure. And so I know what you're thinking, why a separate environment? Why can't we use our public resolver service? And that's exactly was our response as well. Like, come on, like we run a huge complex resolver fleet across the world. Why can't you just use it? Or we have a US only Anycast. Why can't you just use it? But as naive as we were when we were given this task initially, we then realized that in order to operate in a Fedramp environment, there are a lot of Fedramp related controls that you have to comply to, and a lot of them don't make practical sense for our public resolver fleet, and which is why we were tasked to build a completely separate infrastructure on AWS. So the focus of my talk today is going to be one small part of our Fedramp compliance, which is how did we take our software, the resolver software itself, and get it or take it along the way of FIPS compliance. And so in order to understand our approach, it is important to understand a little bit about our software. And so the software running on our public fleet is written in C. It runs on Debian Linux, and it uses OpenSSL to do SSL or crypto operations. We also use libsodium or libnacl for DNSCrypt. So this is the public resolver field. So what is it that we need to do to get to Fedramp compliance? And one of the first things is to get the resolver software FIPS compliant. So, all right. So what options do we have? Right? We are using OpenSSL 1.1.1. In order to get FIPS compliance and do the SSL operations in a FIPS compliant way, we have to use OpenSSL FIPS modules. So OpenSSL has two FIPS modules. The one on the left you can see is FIPS module 2.0. That is FIPS certified. It is compatible with older versions of OpenSSL, namely 101 and 102. It is not compliant with OpenSSL 1.1.1, which is what we currently use. And OpenSSL has not been releasing updates to the FIPS module 2.0. Now, I might even refer to FIPS module as FORM. FORM stands for FIPS Object Module. That's what FIPS module is commonly known as. So we can't, that is one option, in which case we'll have to go back and use the older version of OpenSSL. Or the other option is to go to FIPS module 3.0, which is also FIPS certified. But it's only compatible with OpenSSL 3.0 and 3.1. And because it is on the latest version of OpenSSL code, OpenSSL actively maintains. There are also other SSL providers that you could use that have FIPS certification, but we chose to go the new way, go to FIPS module 3.0. So on this slide, I'm going to talk about some OpenSSL 3 nuances that people working with OpenSSL 3 may be familiar with, others may not be. It's important to understand this for some of the other later design decisions that we made. The majority of the changes in OpenSSL 3.0 are internal architecture restructuring to facilitate a long-term supportable cryptographic framework that enables better separation of algorithm implementations from algorithm APIs that use it. So these structural changes also support a more maintainable, the FIPS cryptographic module or the form. And OpenSSL 3 comes with this provider concept. So providers implement cryptographic algorithms within them and provide supporting services for those algorithms. So pretty much a provider houses implementations for some cryptographic primitives. You can think of it that way. There is also this two important providers that I list here, and default provider and FIPS provider. The default provider is built as a part of the libcrypto library and contains all of the most commonly used algorithm implementations. The FIPS provider is more like a dynamically loadable module that you must load explicitly, either in code or through OpenSSL configuration. It contains implementations that have been validated as per the FIPS 140-2 standard. And of course, a lot of low-level APIs have been deprecated in OpenSSL 3, and we use a lot of them in our code. So I'm going to talk about some of those. And there is a strong push to move towards the higher EVP level APIs. Now, I tried looking up what EVP is, and the answer I came up with is digital envelope. It's not very intuitive, but that's the best I got. Yeah, and what are the challenges we encountered with OpenSSL 3? OpenSSL 3 wasn't available for Debian 10/11 when we started. It was only available for Debian 12. Even the packages that were freely available for Debian 12 weren't built with FIPS compiled. The FIPS object module wasn't available. So we had to build OpenSSL for our own selves with FIPS support, and we packaged it ourselves for our own use. And while packaging it, we have libSSL 3, we have OpenSSL, libSSL-dev, and we package the FIPS module separately. I will come to why we package the FIPS module separately later on. But essentially, the diagram that you see on the left side is how it currently works on our commercial resolver, where you see the other apps, do.DNSSEC using OpenSSL 1.1.1, DNSCrypt at the bottom using libsodium. And the model we wanted to move to is the Fedramp DNS resolver. Have all the other apps, do.DNSCrypt use OpenSSL 3 in FIPS only mode, and then have DNSSEC use a mix of FIPS and non-FIPS. I will talk about this very shortly because that is the most interesting bit of the presentation. So when we look at DNSSEC algorithms, this is a list of DNSSEC algorithms that our public resolver supports. Some others may support a different list. But essentially, the ones on the left that you see are all FIPS certified. The ones on the right, the ED 25519 and ED 448 are not yet FIPS certified. I say not yet. So what does this mean? It means that we will be unable to validate these two algorithms on a FIPS only system. What does this really mean for security, right? If a client is making a query that a resolver is processing and fetching records from upstream, doing DNSSEC validation and giving the answer back, if the zone is signed with ED 25519 or ED 448 and the resolver can't validate it and treats it as unsigned, that automatically means that the resolver is almost downgrading security for that zone. And we really did not like that. And so how do we comply without compromising security is a question we ran into. And the direction in which we went is to, we said, let's do validation. Let's enforce validation failures, but treat successful validations as unsigned. What does that mean? That means if you are asked to validate a zone that is signed with ED 25519 or ED 448, we will treat successful validations as success and return an answer, but with the AD bit unset. So the client treats it as unsigned. So from Fedramp perspective, it's not, FIPS signed, you can say. But what happens in case of failed validations? In case of failed DNSSEC validation, we still enforce it and return a serve fail back, thereby making an attempt to not downgrade the DNSSEC security for the zone. Well, this is all good, but how do you validate these non-FIPS compliant algorithms or non-FIPS certified algorithms on a FIPS system? That is a challenge. So in order to solve this challenge, it is important to understand the OpenSSL3 interactions that take place within our resolvers. So if you look at the bottom portion, on the right side, there is OpenSSL3 with the default configuration that enforces FIPS. So everything on the box gets FIPS by default. But the resolver software uses a custom OpenSSL3 config that gives it the capability to talk to both FIPS provider and the default provider. And both of those providers are enabled in the configuration. Now, this is a deeper look at the previous slide, where what happens within the context of the resolver software itself. So if you can see the top portion, the green portion is all the other SSL crypto operations go to the FIPS provider by default, so they get FIPS. But for ED 25519 and ED 448 operations within the code, we specifically go to the OpenSSL default provider, do the validation, and then when returning the answer back, if it's not in our FIPS certified list, we don't set the AD bit. And yeah, for those of you that that get excited looking at code, this is just an example implementation. Like if we have to fetch a digest implementation in our environment, where we have to support both OpenSSL 1.1.1 code base for commercial as well as support OpenSSL 3 from the same code base. How do we do that? Right? It can lead to a lot of ugly looking code, but then once you've dealt with this, you realize this may be a more elegant way of doing things. So this is just an example. And if you see the middle portion of it, where it says if FIPS mode, then run the OpenSSL API, but go to the FIPS provider. The FIPS equals yes property query string at the end makes the OpenSSL APIs use go to the FIPS provider if it's available, and go to the default provider for non-FIPS mode if it's enabled. So that was about DNSSEC. What about DO and DOT? DO and DOT was a little bit easier for us to solve, because what that means for DO and DOT is FIPS just restricts the list of ciphers that get advertised during SSL handshake. And that's now going to be a little bit smaller list. OpenDNS resolvers already support, restrict the ciphers to a small subset due to internal company requirements. And that list for our commercial resolvers includes the ChaCha 20 and Poly 1305 based ciphers. So in FIPS mode, these ciphers won't be advertised for HTTPS or SSL handshake. And how do you do that? How do you handle these connections and make sure that the DO code goes to the FIPS provider explicitly in the code? There are similar SSL APIs. This is just an example to create an SSL context. And you can see this piece of code kind of works with both OpenSSL 1.1.1 and OpenSSL 3. And OpenSSL 3.2 has two flavors. One is FIPS mode and one is provider equals default. So this is how you could do it in the code. It took us a bit of experimentation to get this right, but that's an example. FIPS compliant DNSCrypt. A colleague of mine, Brian Somers, presented about DNSCrypt and encryption scheme 3 in the previous OARC 40 at Atlanta. So you can go and take a look at the recording, but I will just cover like some salient points. So we were, at the time of the presentation, he had said that we are working on getting an RFC draft ready. But then before we published that draft, Frank Dennis beat us to it. And he submitted a draft already. And so we are working on like making updates to that draft and proposing the new encryption scheme. So our proposal is to have a new encryption scheme, ES3, with a new DNSCrypt version, that's DNSCrypt version 3. Version 1 uses Salsa, I think, and version 2 uses Cha-Cha, if I'm not mistaken. So ES3 is a new FIPS compliant DNSCrypt scheme we are proposing, and ES1 and 2 won't be supported. So if any client wants to talk to us using DNSCrypt into the Fedramp resolvers, they would have to use the encryption scheme 3. And then there are some other considerations as well. This is pretty much my last slide. After this is references. So what are some of the other considerations? So I'd like to talk a little bit about this here because this will spark some conversations, and I'd really like to understand how other folks in the industry are doing this, learn from your experiences as well. So we had to provide or enable protective DNS feature into our resolver service. We had to build it. That was one of the requirements. And the others are around tooling and environment-related changes. The security and compliance, this is the most important one. I'm going to spend a minute here. Now, OpenSSL frequently releases updates to their code and their versions, and the updates may be based on vulnerabilities. But FIPS module itself takes time to get certified. To give you an example, the latest OpenSSL 3 version, the 3.0 version is at 3.0.10, but the FIPS module or the FIPS provider that is FIPS certified is still at 3.0.8. What if there are vulnerabilities in the FIPS module itself between those two versions? Can we install, for example, 3.0.10 FIPS module on our FIPS or Fedramp resolver in the name of security or in the name of compliance? Should we not install that and continue running with FIPS certified FIPS object module? I don't know the answer to that question. We are still in, having some of those discussions right now, working with our sponsor. But if some of you have already solved this, I'd really be interested to hearing. Yep, and these are some of the references. There are some links there that I described for each of them. So if anyone's more interested in OpenSSL 3 and figuring out how it works, take a look at some of these links, and they're really, really interesting. With that, I'm done. I can take questions now.
Victor Dacconi wants to know, did you run into any performance issues with OpenSSL 3.2?
That's a very, very good question. In fact, just last week, I was running some benchmarks against it. And to answer to Victor's question, we didn't essentially performance test OpenSSL 3 or 3.1 itself. We performance tested a resolver in context of OpenSSL 3 and 3.1. In fact, I ran those performance tests against 3.0.10 and 3.1.2. And bear in mind that those tests were conducted within our usual performance benchmarking frameworks. So there's a lot of queries that are being sent, mostly DO dot, and we tested with different combinations, DO dot, and the only other SSL part that's happening within the resolver is for DNSSEC or DNSCrypt. But we didn't test DNSCrypt yet. for do and dot and DNSSEC validations happening, we did not notice significant performance degradation, at least based on the hardware that I was running, which was really encouraging. As I said, the performance test was in the context of a resolver as a whole and not just done as a means of benchmarking OpenSSL. And we might even have a present at the next OARC, maybe our findings.
Hey, this is Shimon Huck with Salesforce. So you started your presentation saying, why don't you just use our existing global network? Why don't you just use our existing global network? Why do we have to build in this new capabilities? So I didn't understand, in the end, are you building a version of your resolver network specifically tailored to the US government that only they use, that has these FIPS compliant features? Or are you upgrading your wholesale, your entire network to be FIPS compliant?
That's a good question too. I'm sorry I didn't explain that properly. So with respect to the DNSSEC limitations that I just explained, and there are a lot of other environmental restrictions that are being applied. So we are not planning to run our public resolvers in Fedramp mode or in FIPS only mode for now. Okay. It's a separate environment that's being built, but an environment that we'd like to keep as close to our commercial as possible and not deviate too much, because anytime we deviate too much, it leads us to more management headaches, which is one of the reasons why I said we're trying to maintain both OpenSSL 3 and OpenSSL 1 support from the same code.
Right. Yeah, it sounds very familiar. So our company, we also offer Fedramp compliance services for the US government, but it's a separate environment. We try to keep the deltas as small as possible, but it's not really possible. They're different, right? Yeah. And then the other quick comment before I leave is I did look up, I was just curious because I thought I remembered FIPS now supports at 255.19 and 448. And it turns out it does. Earlier this year, I think I just looked it up, FIPS 186.5 does. However, I think if I remember, the Fedramp specifications reference specific versions of NIST documents. I don't know if those have been updated. Maybe you already know the answer to that.
Yes, and that's why I said they're not yet supported.
Okay.
We are waiting on them. Once it gets certified, then we will likely not need to use this CRUFT in order to support ED 25519 and ED 448. Okay. We are hoping that happens soon.
Yep. Thank you.
Thank you, Shuman.
So I had one question. I'm Pallavi from Salesforce. How do you expect your clients to use it? Do they do at 1.1.1 type call your resolver, or because sometimes what happens is for Fedramp, the government customer expects the resolver to be deployed within our infrastructure. So do you have plan to extract that piece out and give it so that people can deploy it in their own infrastructure?
It's a good question too, Pallavi. So, I'm trying to figure out how to place my answer. So, we have separate NLB addresses for Fedramp resolvers. They're not using any cast at this point. They're using Amazon network load balancer. So they're behind a separate infrastructure. So there are separate set of IPs published so people can reach us on the separate IPs. We don't yet have Fedramp customers yet. So we just got authority to operate, and we are moving ahead with the other parts of Fedramp. That's hopefully answers the first part of your question. The second part is that we will still be responsible for running those Fedramp resolvers. It's not running in a separate government we still have control over it within Cisco, but they're running in a very specific portion of AWS cloud. I think we call it the Gov Cloud and Gov DNS. Those are Fedramp certified clouds, environments that we can run our resolvers on that take care of a lot of backend compliance work. So,
thank you, Prashanth.